Hello, so this is a revision video for AP Chemistry 3.10, Solubility. Solubility describes how well a substance, the solute, dissolves in a solvent to form a homogeneous mixture or solution. Whether or not a solute dissolves depends on the intermolecular forces between particles of solute and solvent. The general rule used in chemistry for solubility is like dissolves like. Polar solutes tend to dissolve in polar solvents. Non-polar solvents tend to dissolve in non-polar solvents. This rule is based upon the compatibility of intermolecular interactions. If the solute-solvent interactions are similar in strength or stronger than solute-solute and solvent-solvent interactions, the solute will likely dissolve. So solubility is the ability of a substance, a solute, to dissolve in a solvent to form a homogeneous solution. Water is a highly polar solvent and can form hydrogen bonds. This makes it very effective at dissolving ionic compounds and small polar molecules. When ionic compounds dissolve, water molecules surround and separate the ions in hydration. Positive ions are attracted to the partially negative oxygen in water, and negatively charged ions from the compound are attracted to the partially positive hydrogen in water. This process is called hydration. If the hydration energy is greater than the strength of attraction holding the lattice together, lattice energy, the compound dissolves. In other words, if the strength of attraction between the water molecules and ions is comparable in strength to the strength of attraction between the ions in the compound, the ionic compound can dissolve in water. As well as dissolving ionic compounds and small polar molecules, water also dissolves some molecules that can form hydrogen bonds, such as ethanol and ammonia. It is the high relative strength of these hydrogen bonds that can form between these solute molecules and water molecules that make them soluble. In other words, the strength of hydrogen bonding that can form between the solute molecules and water molecules is comparable in strength to the strength of hydrogen bonding that can form between just water molecules. Exam tip here. Whether a substance dissolves in water depends on the relative strength of interactions between solute and water molecules compared to the interactions within the solute itself and within water. For example, ethanol is soluble in water because the intermolecular forces between ethanol and water molecules are similar in strength to the forces between only ethanol molecules and only water molecules. These comparable attractions make it energetically favorable for the substances to mix. Water is a poor solvent for large molecules that cannot form hydrogen bonds, for example, halogenoalkanes, and non-polar molecules, for example, iodine and hydrocarbons. These substances cannot interact favorably with water's hydrogen bonding network and are therefore insoluble or only partially soluble. This means it is more energetically favorable for water molecules to simply hydrogen bond to each other rather than mix with the solute molecules. For substances that don't dissolve in water, non-aqueous solvents can be used. These solvents don't rely on hydrogen bonding and instead dissolve substances through London forces or dipole-dipole interactions. Solubility in these solvents depends on matching the type of intermolecular force. Non-polar solutes dissolve in non-polar solvents.